Today we'll look at inelastic collision in two dimensions. In our previous classes, we defined collision, and we said that collision is of two kinds: elastic collision and inelastic collision. And we looked at them in one dimension. So today we'll be looking at inelastic collision in two dimensions. To refresh our memory, we know that in the case of inelastic collision, only momentum is conserved after the impact. Kinetic energy is not conserved. So in the case of inelastic collision in two dimensions, let's look at this diagram on the board. This is a mass, a body with mass m1, another body with mass m2. This body are moving with initial velocity u1 and u2, and this body is moving on the horizontal, m1 is moving on the horizontal axis. It means no angle is involved here. It's m2 that is moving at an inclined angle of θ1. So after the impact, after collision, they will move with a common mass and a common velocity. So looking at the conservation law of momentum of a body in the case of inelastic collision, we say consider two bodies of masses m1 and m2 at an angle θ1 to each other with an initial velocities u1 and u2. They undergo a perfectly inelastic collision at a point B. The two masses stick together to form a single mass m, which then travels with a final velocity v, making an angle of θ2. So for the principle of conservation of momentum, we can say that m1 u1 plus m2 u2 equal to mv, because after collision they move with a common mass and a common velocity. So we now write this in terms of both x and y component, because we're talking about 2D. So for the x component, we now say that m1 u1 cos 0, because for m1 the angle is not involved, plus m2 u2 cos θ1 equal to mv cos θ2. But we know that cos 0 is 1. So this equation can be written as m1 u1 plus m2 u2 cos θ1 equal to mv cos θ2. Then for the y component, we can write this as m1 u1 sine 0 plus m2 u2 sine θ1 equal to mv sine θ2. So we can now write this as sine 0 is 0. So the whole of these components becomes 0. And then we have m2 u2 sine theta 1 equal to mv sine theta 2. So this is how we can resolve this in the case of inelastic collision in 2D.